Hello class. So last time we were talking about exponential growth and exponential decay. So remember our standard equation was a times b to the x, and that was our standard exponential function. And then we had conditions on b, right? So if b is bigger than 1, our graph would look like this. It goes through the point 0a, and the horizontal asymptote is y equals 0. And if b was between 0 and 1, it still goes through 0a, but it kind of goes backwards. And the horizontal asymptote on the other side is y equals 0. So these were our two examples of exponential growth and decay. So today we're going to talk about percent increase and decrease. Okay, so percent increase and decrease. All right, and here's what we're going to do. This is going to be usually it's talking about amount of money here. So if we're talking about increase, we're going to say A equals P times 1 plus R to the T. Okay, and the idea is P is what you're starting with, R is your interest rate, your percent increase or decrease, in this case increase, and then T would be the amount of time over whatever time period you're talking about. So for money it'd probably be like years. Okay, so this would be increase right here. Okay, and then A equals P times 1 minus R to the T. This would be decrease. And just so we can compare, this is like your A, that's like your B, and then your T is like your X. Okay, so it's like A times B to the X and so forth, and A, B to the X. Okay, so this should correlate exactly to what we talked about last time in terms of A times B to the X. Alright, so let's just do an example problem. A lot of these are word problems. Okay, so a gold coin is purchased for, I don't know, let's say $300. The coin increases in value. Put that up here so you can see it. So it increases at the value yearly at a rate of 2%. Okay, so if we want to know a function that's going to tell me what the value of the coin is worth at any time, so here P is 300. Okay, my interest, my R is going to be 2%, but we need to write that as a decimal. Okay, so that's 0.02. Remember, you take 2 and the decimal point when it's percent, and you move it 2 to the right and add zeros if you need to. So that's how we're going to get 2%. And T is going to be time in yearly. Okay, so A would be 300 times 1 plus 0.02 to the T. So this would be the function that represents the amount of the coin is worth at any time T. Or usually we just go ahead and combine the 1 plus 0.02, and this is 300 times 1.02 to the T. Okay, so our next question might be what is the value of the coin after 5 years? Okay, so we're going to take the equation that we just wrote. All right, so we're going to take this A equals 300 1.02 to the t, and we know t is in years and it says 5 there, so we're just going to plug 5 up there. So we get 300 times 1.02 raised to the 5th, okay? And then you punch that in your calculator, and when I did that, when I punched that into the calculator, I got 331 and 22 cents. Okay? So that's one way of dealing with percent increase. Okay? But let's do a decrease problem. Okay? So we're going to purchase a car. Okay? A car is purchased for $20,000. It's a reasonable price for a brand new car, right? A sedan or something. Okay, so a car is purchased for $20,000, and depreciates at a yearly rate of 13%. Okay, that's actually kind of low. Okay, so we want to know. So just let's think about this. Let's make it as real as possible. So normally, if you're buying a car and you're doing car payments, your payments are going to be over 5 years. So that's 60 whole payments. So one every month for 5 years, because 12 times 5 is 60. 12 months in a year. So you would hope to pay off your car and maybe have a little bit of time where you don't have to have any payments. So let's say we want to know how much is the car worth in 7 years. Okay, so look, we buy a new car, we pay it off for 5 years, we own it for 2 more years, and we're happy we don't have to pay any payments. But then we kind of get tired of our car and we want a new one. So this is the idea. All right. So in this case, A is going to be P times depreciation means decrease. Okay. So decrease. Okay. So A equals P times 1 minus R to the T, and P is 20,000. Okay. R is 0.13, or that's your 13 moved 2 decimal places over. T is eventually going to be 7, but for the moment, let's say this. So let's say R equals 20,000, 1 minus 0.13 to the T. Okay, so that's our function for how much the car is worth at any time T, and we want to simplify that just a little bit. So 1 minus 0.13 is 0.87. Okay, so this is how much our car is worth at any time T, and 7 years later, we're going to have A equals 20,000 times 0.87 to the 7. Okay, so the idea is this is how much we're going to get for a trade-in on our car. So this is how much we can put down on the next car we want. Okay, so I got, when I plugged all this in, I got $7,545.10. I'm sure they wouldn't care about the 10 cents. So there you go. And that is percent increase and percent decrease. So furthermore, if you got something where it's 100 times 1.13 to the T, that's a 13% increase. Okay, and if you have, let me write that so you can see it. So 100 times 1.13 to the T, the 0.13 is your increase. And then if you got a number that's less than 1, so let's say 30 times 0.85 to the T, well, you would do 1 minus 0.85, okay, and that's going to be 0.15. Here, let me make that clear. So 0.15, so that's a 15% decrease. Okay? So increase is bigger than 1, decrease is smaller than 1. All right?